What if I told you that astronomers have uncovered something so vast it shouldn't exist at all according to the laws of physics? A structure so immense that light, traveling at 300,000 kilometers every second, would need 15 billion years just to cross it. Discoveries like this shake the very foundations of cosmology. But to truly appreciate how extraordinary this is, we need to build up our sense of scale, starting with the familiar, before venturing into the unimaginable. Our journey begins on Earth, a fragile sphere measuring just under 13,000 kilometers across. Every war, every invention, every love story in human history, all of it has taken place on this tiny planet. Now let's introduce our universal measuring stick, light. In 1 second, it can zip around Earth more than 7 times. That's how fast it is. And yet, to cover the distance to our moon, about 384,400 kilometers, it still needs a little over 1 full second. If you took a regular airplane flying at 1,000 kilometers per hour, the trip would last 16 days of continuous flight. The moon feels close, but already we see how empty space really is. Next, Mars. At its closest approach, the red planet sits 56 million kilometers away. To fly there at passenger jet speed, you'd need more than 6 years without stopping. And then, our parent star, the Sun. Its average distance from Earth is 150 million kilometers, known as 1 astronomical unit. Light takes 8 minutes and 20 seconds to bridge this gap. If the Sun vanished right now, we wouldn't even notice until those minutes had passed. Let's move outward. Neptune, the most distant planet, orbits at about 4.5 billion kilometers, roughly 30 times farther than Earth is from the Sun. A beam of sunlight requires 4 hours to reach it. A plane? Almost 5 centuries. And beyond Neptune lies the heliopause, where the solar wind collides with the interstellar medium. It's here that the Sun's influence ends and the galaxy begins. Now the numbers explode. The nearest star system, Proxima Centauri, is 40 trillion kilometers away. That's 270,000 astronomical units. To put this into perspective, if Earth were shrunk to the size of a coin, Proxima Centauri would still be several thousand kilometers away. Inside the Milky Way, stars are separated on average by more than 300,000 astronomical units. Among them are giants like Betelgeuse, which swells nearly 1 billion kilometers in diameter, large enough to engulf the orbit of Jupiter. And yet, from our vantage point, it is nothing more than a tiny orange point of light. Our galaxy is a majestic spiral about 100,000 light-years across, home to perhaps 400 billion stars and their planets. Even traveling at light speed, it would take 100,000 years to cross from one side to the other. But the Milky Way isn't alone. It's part of a family of galaxies called the Local Group, which includes Andromeda and dozens of smaller galaxies. Together, this group stretches a few million light-years across. On a larger scale, galaxies arrange themselves into clusters, and clusters bind into superclusters. These superclusters don't float in isolation. They weave together into the cosmic web, an immense structure resembling filaments and voids stretched across the universe. Here's where the unimaginable begins. Astronomers discovered the Hercules Corona Borealis Great Wall, the largest known structure in the observable cosmos. Spanning nearly 15 billion light-years, it dwarfs everything else we've ever measured. And here lies the mystery. According to the cosmological principle, the universe should look smooth and uniform on very large scales. Theoretical limits suggest that no structure larger than 1.2 billion light-years should exist. Yet the Hercules Corona Borealis Great Wall is more than 10 times that size. It shouldn't be possible, and yet it is. This forces us to reconsider the very framework of our cosmology, how galaxies form, how matter is distributed, and even how the universe itself has evolved. From the fragile skin of Earth's atmosphere to the edge of the observable universe, each step outward reveals scales that defy human imagination. And the deeper we look, the more questions arise. If something as vast as this Great Wall can exist, what else might be waiting beyond the reach of our telescopes? In the end, the universe does more than overwhelm us with size. It humbles us, reminding us that we are part of something boundless, mysterious, and still largely unknown.